Okay, so we're going to look at how to draw Lewis structures for molecular compounds and polyatomic ions. And these are the common sorts of things we draw Lewis structures for. So here's a list of directions. It's really more guidelines than a to-do list. The first place to start is to get the correct skeletal structure of the molecule. How are the atoms connected to each other? And this is not always obvious, especially to beginning chemistry students. So hydrogen atoms are always terminal. Terminal means that they're on the outside, on the ends of the molecule, because hydrogen atoms can only bond to one other element, so they can't be between elements. Another guideline is put the more electronegative atoms in the terminal positions. And then sometimes you just kind of have to play around with it and try out a couple things. Sometimes the problem will actually tell you which element to put in the middle, because there's no way you would be able to figure it out by yourself. Step 2 is figure out how many valence electrons there are. So total number of electrons for the Lewis structure. The Lewis structure only shows valence electrons. So we just add up the valence electrons for each atom in the molecule, and then if it's an ion, you have to think about the charge. That'll cause the number of electrons to be more or less. Next, you're going to take those electrons and distribute them among the atoms, trying to make everybody happy. Everybody but hydrogen wants an octet. Hydrogen wants a duet. Hydrogen is very easy to satisfy. He makes one covalent bond. He's good. So he's a squirrel when it comes to other things, but here he's just a little angel. He just sits there and he's happy. Sometimes you can't make an octet for everybody using the available number of electrons, and so that means we need to do more sharing. So if you can't make octets, then we're going to go to double or triple bonds as needed. Okay, so let's do some examples. Write the Lewis structure for carbon monoxide. I'm not sure why I'm on purple here, but let's get back to a more reasonable color.
What's wrong with purple?
It doesn't coordinate with the slides, right?
That's really weird.
Lewis structure for carbon monoxide. So the first thing is connect the elements. So this one's easy. There's only two. They've got to be connected to each other, right? So carbon next to oxygen. I'm drawing a line between them because there needs to be at least one single bond between connecting atoms, or it wouldn't be a molecule. Then we're going to figure out how many electrons. How many valence electrons does carbon have?
4.
4. And how many does oxygen have? 6. So 4 plus 6 is 10. So we've got 10 electrons to distribute. There's 2 in this bond. Remember, you can think of each of those bonds as being a line connecting 2 electrons. So there's 2 electrons. Now we do counting by 2s. 2, 4, 6, 8, 10. So I ran out of electrons. Are these atoms happy? No. That means we need to do more sharing. We can't just import some electrons. And when I distribute these, I tend to just kind of do it symmetrically, scatter them around. There's no right or wrong way to do it. So what I'm going to do now is I'm going to take one of these pairs that's not shared, and I'm going to share it. I'm going to take that pair off of carbon, and it's going to be shared between carbon and oxygen. So now the carbon has 2, 4, 6. So carbon didn't benefit from that, but this oxygen has 2, 4, 6, 8. The oxygen has an octet. Carbon's not happy. We do need to make everyone happy. It's not real possible in life, but it is possible here to make everyone happy. So I'll take that lone pair from oxygen and share it with carbon. I still have 10 electrons in my diagram here, my structure. I've got 2, 4, 6 in bonding pairs, 8, 10. Each of these atoms has an octet. Any questions? Okay, let's do H2CO. This one's a little more complicated. First thing is figure out how are the elements connected. Well, probably carbon is connected to oxygen, And then we've got 2 hydrogens. We know those aren't in between because they have to be on the outside. So then we have to say, well, is it connected to the oxygen? Is it connected to the carbon? So one thing that can help us is to look at the relative electronegativities of carbon and oxygen. Which one's more electronegative? Closer to fluorine. Oxygen. Oxygen's more electronegative, so he's probably going to be in a terminal position as well. So we'll try putting those hydrogens on the carbon. Then we have to count up electrons. Well, we've already assessed that carbon has 4, oxygen has 6, and then there are 2 hydrogen atoms. They each have 1 valence electron. So this element has 12. We've already got 2, 4, 6 in those bonds. So 6, and we go 8, 10, 12. That's exciting, huh? Are we good? No. Oxygen's not happy. Carbon's happy. So what I want to do is I want to take this lone pair of electrons on the carbon and share it with the oxygen. I want to take this one, because if I share one of oxygen's lone pairs, then carbon's going to end up with too many. So I think of it as, so carbon is in a place of strength. Carbon's happy and satisfied. And so carbon's like, hey, I can help you out. I'll share my lone pair with you. So I take this one and we stick it over here. Same number of electrons, but now octets for everybody. Any questions?
Carbon likes to be in the middle a lot, right?
Carbon does like to be in the middle. Yeah.
So self-centered.
Self-centered. Carbon's very friendly. Carbon likes to make 4 bonds. Yeah.
How do you know which one's going to be in the middle? Like in some cases.
Right. It's not always obvious. We're going to learn about formal charge in a few minutes, and that'll help us to understand. But on this one, I would go with the oxygen being more electronegative is probably going to be in the terminal position.
Meaning it's not going to be the center.
It's not going to be in the middle. It's going to be on an end. So in this molecule, oxygen is terminal and the 2 hydrogens are terminals. It's a little bit like an airport, where here's the main hub of the airport. You know, this is where you go in, and then the terminals are these long hallways, these wings that stretch off, right? And you go out there and you catch your airplane. You don't walk to the end of the terminal and go anywhere else, because it terminates. It's the end. Another thing that can help us, and this will tie into formal charges that we'll get to, but I think this is cool, so I want to show you. So how many bonds does carbon have in that molecule?
Which one? The top or the bottom?
The bottom one.
That has 4.
It has 4. It's bonded to 3 atoms, but there's a double bond. A double bond is 2 bonds. So 4 bonds. Well, let's look at the Lewis structure for a carbon atom. How many valence electrons does it have? 4. 1, 2, 3, 4. So carbon is set up to make 4 bonds. Each of these single electrons shares well with something else. Let's look at oxygen. How many valence electrons? 6. 1, 2, 3, 4, 5, 6. You're going to end up with 2 pairs and 2 singles, and this electron and that electron are going to bond with something else. Oxygen likes to make 2 bonds. Let's look at nitrogen. How many valence electrons? 5. How many bonds do you think nitrogen likes? 3. So this will usually be a lone pair, and then it'll use these electrons to bond with other atoms. And then let's say chlorine. How many valence electrons? 7. Chlorine tends to make 1 bond. It's not a hard and fast rule, but it's a trend.
The one that's not paired is the one that's going to
Yeah. The electrons that are not paired when we draw this Lewis structure are the ones that are going to form bonds with other atoms. And that there's a scientific explanation underneath that, but it's going to take us a while to get there. Okay, let's do an ion. This is hypochlorite ion, which actually is in one of the modules. I don't know why they did that. Anyway.
Yeah, this one.
This one gave you trouble last night, and it shouldn't have. So connecting, in fact, I'm going to do it the other way just because it's also okay to do it like this. He had everything right and it counted it wrong, and I have no idea why.
And it does a terrible job. Like, it makes you think that you have to put the brackets around and then the charge.
I should have warned you about that. Okay, so mastering chemistry doesn't do brackets. I don't know why. You would think that they do all kinds of other things. Why not brackets? Mastering chemistry cannot do brackets for ions. So just be aware of that. It's stupid. But we're not going to throw the whole program out just because of that. No, we can't. Okay, so chlorine has 7 valence electrons. Oxygen has 6 valence electrons. That negative charge, do I add one or subtract one? We add one. A negative charge means we have an extra negative charge. That's not confusing at all. 14 electrons. Okay, so I've already got 2, 4, 6, 8, 10, 12, 14. Nice. I had enough to give everybody an octet and to just have single bonds. But this is an ion. And so when you're not doing this in mastering chemistry, we have to put brackets around this and put the charge on the outside of the brackets.
So we show how many electrons it has in the Lewis structure, but because it's an ion, we have to show the charge.
We have to show the charge, because otherwise someone, if we're writing this for chlorine monoxide, this would be wrong, because there's too many electrons. So when there's a charge, we have to indicate it. That messed some people up on the last exam.
So it has an okay, I got it.
This is not the same as ClO.